A number of the form a plus ib, where small a comma small b belongs to real number, where small I equal to square root of -1 is called a complex number. So, continuing complex number, today we discuss a cube root of a complex number. So, let's start. So, students, what is cube root of unity? Today we discuss what is cube roots of unity. The first topic is cube roots of unity. So now start. Let z equal to 1 to the power 1 by 3. This is the cube root of unity, or you can write it as cube root of 1. What is the value of this? We discuss now. So z cube equal to, cubing on both the sides, we'll see 1 to the power 1 by 3, that is 1, implies that z cube minus 1 equal to 0, implies that z cube minus 1 cube equal to 0. So just factorize a cube minus b cube for your code. Z minus 1 into z square plus z plus 1 equal to 0, implies that, a into b equal to 0, that means a equal to 0 or b equal to 0 or both equal to 0. So z minus 1 equal to 0 or z square plus z plus 1 equal to 0. So implies that z equal to 1, and by quadratic formula z equal to minus b plus minus root over, okay, a, b, c are what? 1, 1, 1, 1, 1, 1. So minus b plus 1 is root over b square minus 4ac divided by 2a. So that is what? Minus 1 plus minus root over minus 3 by 2. That means minus 1 plus root 3i. Okay. So this side we write. So z equal to, finally what we got? 1 minus 1 plus root 3i divided by 2, and minus 1 minus root 3i divided by 2. Where we got I? So root over minus 3. What is the meaning of root over minus 3? Root 3 into root over minus 1. Root 3 into I square root over, that is root 3i. Okay. So z value, we got the cube root of 1, means the value of z equal to 1 minus 1 plus root 3i by 2 minus 1 minus root 3i by 2. So here 1 real number and 2 imaginary number we are getting. So this is cube root of unities, the introduction. So now come to next. Properties of cube roots of unity. So each complex cube root of unity is the square of other. Okay, sure. What we'll do? That three numbers we got now, z equal to 1 minus 1 plus root 3i divided by 2 minus 1 minus root 3i divided by 2. We call it 1 omega square. If we call this value is omega, this value must be omega square. Why we discuss here? Each complex cube root of unity is the square of other. How? Suppose the second complex cube root. Three cube roots are there. One is real, this one is real, and this one is complex, and this one also complex cube roots. So one complex cube root to discuss, minus 1 plus root 3i divided by 2, its whole square. Okay, according to this property, whole square of the second value, that means minus 1 plus root 3i by 2, its whole square is equal to the third value. How it will come? So now minus 1 square, that is 1. plus root 3i square, 3i square, plus 2ab, plus 2 into minus 1 into root 3i divided by 2 square. What is the value of 2 square? That is 4. So 1 minus 3 is what? Minus 2 minus 2 root 3i divided by 4. Now 2 to cancel out. Minus 1 minus root 3i by 2, which is the third cube root. I mean omega square. So omega and the third cube root of unity, that is called omega square. And if I want to square that one, minus 1 minus root 3i by 2 whole square, definitely you will get the second cube root of unity. So square it, 1 plus a square plus b square, 3i square plus 2ab plus 2 root 3i divided by 2 square is 4 equal to 1 minus 3 because I square is minus 1. So 1 minus 3 minus 2 plus 2 root 3i by what? 4. That is 2 to cancel out. Minus 1 plus root 3i by 2. So this one is the second value and this one is the third value. Third cube root. So second complex cube roots square will be the third complex cube root and third complex cube roots square will be the second value. So if I'll take this as omega, this must be omega square. If I'll take this as omega, this must be omega square. No problem. You can take this one omega. But in general, we are taking the second one as omega and the third one is omega square. So remember here that the second value square must be the third value and third value square must be the second value. It happened only in case of complex cube roots. So come to next property. Property number 2. Integral powers of omega. Since we know omega satisfies z cube minus 1 equal to 0. Because from z cube minus 1 equal to 0, after solving we are getting 1 omega square. So z cube minus 1 equal to 0. That means that is that in place of z, if I write omega, then it's true. Implies that omega cube equal to 1. So that means omega cube equal to 1. This is the power of omega. So omega power 3 equal to 1. Omega power 1 equal to what? Omega. Omega power 2 equal to what? Omega square. Omega to 3 equal to what? 1. Omega to the 4 equal to what? Omega cube into omega, that is omega. Omega to the power 4 equal to what? Omega cube into omega to the power 4 completed now. Omega to the 5 equal to what? Omega to the power 3 into omega square. But omega to the 3, omega to the power, okay, again. Omega into omega equal to omega. Okay, omega cube into omega equal to omega. Now omega to the 5 equal to what? Omega cube into omega square. That is omega square. See, similarly, if I want to know omega to 100 equal to what? You'll write omega to the 3 to the power 33. That is omega to the 99 into omega. That means omega. Omega to 100 equal to omega. So in this we can write omega to the power n equal to omega to the power r, where n divided by 3. When n divided by 3, when n is a non-zero number, okay, n is a non-zero number, divided by 3, getting RH remainder less than 3. Suppose omega to the power 13. That is, if I divide 13 with 3, then what happened? 13 to 12, 0. I'll get 1. So 1 is a remainder. So this value will be omega to the power 1. That means omega. So omega to the 13 will be omega. So now in this way, any power of omega we can find out. Like omega to the power 50. So 50 divided by 3, 3 on the 3, 3 is 6, 18, 2. So omega square. Or simply you can write that 3 divide 50 divided by 3. 50 divided by 3 and 2 is the remainder. Omega square answer. If omega to the 51, then what happened? 51 divided by 3, 17. Okay, well divided and remainder is 0. So here answer is 1. And omega to the 52, then what happened? Omega to the power 51 plus 1, 51 well divided and omega to the 1, that is omega. So properties of cube root of unity, the second property, integral powers of omega. Omega is any power. The n is a non-zero value. So omega n equal to omega r. When n equal to what? N equal to 3m plus r. If n represented as 3m plus r, then you just write omega to the power r and nothing extra. Suppose omega to the power 19. So omega to the power 3 into what? 3 6 18 plus 1. So answer is omega. 3 into 6. Okay. 3 into 6 plus 1. So answer is omega to the power 1 or omega. Okay. So now come to the next topic. Next property. Next property is the sum of three cube roots of unity is cube. The sum of the sum of three cube roots of unity is 0. How to prove it? Means 1 plus omega square equal to 0. How to prove it? It is very simple. Just take 1 and value of omega is minus 1 plus root 3i by 2. What is the omega square value? Minus 1 minus root 3i divided by 2. Okay, equal to, take LCM 2. So 2 into 1, 2 plus minus 1 plus root 3i plus minus 1 minus root 3i. Now see, root 3i, root 3i cancel. 1, 1 minus 2 and plus 2 cancel out. So answer is 0. So 1 plus omega square equal to 0. Or okay, 1 plus omega square equal to 0. This is the property. Suppose 1 plus omega, that is equal to what? Minus omega square. Okay, 1 plus omega will be what? Minus omega square. And 1 plus omega square will be what? Minus omega. Suppose we require omega plus omega square is what? You can write minus 1 or omega into omega plus 1. That is also minus 1. So this property over. So now come to next property. Property number 4. In property number 4, the product of three cube root of unity each 1. 1 into omega into the third cube root is omega square. If you multiply them, you will get omega cube. But we know omega cube equal to what? 1. So now another process is there also for this to prove LHS. Suppose 1 into omega means minus 1 plus root 3i by 2 minus 1 minus root 3i by 2. So now multiply it and find out the value will be 1. So how I will multiply? So 1 multiply. So minus 1. This is a plus b and this is a minus b square minus b square. So minus 1 square minus root 3i square divided by 2 square, that is 4. So minus 1 square is what? Plus 1 minus root 3 square is 3i square divided by 4. So now numerator 1 minus I square is minus 1. So 1 minus 3 into minus 1. So that is 1 plus 3. That is 4 by 4 equal to 1. So product of three cube roots of unity is 1. 1 into omega square equal to definitely 1. So now understood? So this property also done. Now we'll come to the next property, property number 5. In property number 5, we can see each complex cube root of unity is the reciprocal of the other. So now, each complex cube root of unity, that means what? Complex cube root of unity means omega and omega square. So it says that omega equal to 1 by omega square or omega square equal to 1 by omega. To prove this one, we have to prove. Okay, we have to put this one. Omega equal to 1 by omega square and omega square equal to 1 by omega. Okay, so now see, omega cube equal to 1. Everyone know it. Omega cube means what? Omega into omega square equal to 1. That means omega equal to what? 1 by omega square. Look now one thing. And another value. If I write omega square, definitely 1 by omega. From this concept, from this omega cube equal to 1, omega into omega square equal to 1, so omega equal to 1 by omega square. So you can write one complex cube root will be the reciprocal of the other, and the other will be reciprocal of the first. Okay, so this topic also, this property also I have completed. So now come to property number 6. Property number 6 says that cube root of minus 1 or minus 1 minus omega and minus omega square, where omega is the complex cube roots of unity. So we know z equal to 1 to the power 1 by 3. That means 1 omega omega square. Already we have put this in first page. So now see, z equal to this one. Now we want to prove z equal to minus 1 to the power 1 by 3. Then what is the value of z? Then what are the cube roots? So how to do this? So let us cube on both the sides. Z cube equal to minus 1. And z means we can write minus z cube equal to what? Plus 1. Okay. Or you can write like this, minus z cube equal to plus 1. So this minus 1 I have taken to left hand side. So this is minus z whole cube equal to plus 1. So now minus z equal to what? 1 to the power 1 by 3. But 1 to the power 1 by 3, I know 1 omega omega square. Now what I'll do? So z equal to, so minus z equal to 1 omega omega square minus z equal to 1 omega omega square. So z equal to what? Minus 1 minus omega square. I think everyone understood this. Okay. So 1 to the power 1 by 3. That value is 1 omega omega square. And minus 1 to the power 1 by 3, its value also minus 1 minus omega square. So after finding this 1 cube root and minus 1 cube root, what we will do? We can find the cube root of any real number. Suppose A be a positive real number. Suppose A be a positive real number. Then what happened? How to find the value of a to the power 1 by 3? You'll write its answer will be a to the power 1 by 3. A to the 1 by 3 omega. A to the 1 by 3 omega square. Similarly, suppose B be the negative real number. So then B's cube root will be what? B's cube root will be b to the power 1 by 3, b to the power 1 by 3 omega, b to the power 1 by 3 omega square. So this is the answer. Or we can write in this way also. Suppose A be the negative real number. Same A be the negative real number. Then what is the value of A to the power 1 by 3? You can write minus A to the power 1 by 3 minus mod A to the power 1 by 3 minus mod A to the power 1 by 3 omega and minus mod A to the power 1 by 3 omega square minus mod A to the power 1 by 3 omega square. These are the cube roots of any value. So suppose we take one example. Suppose we have to find out the cube root of 8 to the power 1 by 3. What will do? 8 to the power 1 by 3. Its answer will be 8 to the power 1 by 3. 8 to the power 1 by 3 omega 8 to the power 1 by 3 omega square. That means 2 omega and 2 omega square. Similarly, I want to find out minus 8 to the power 1 by 3. What I'll do? Minus 8 to the power 1 by 3. Minus 8 to the power 1 by 3. Okay. Omega minus 8 to the power 1 by 3 omega squared. So it is minus 2 omega and minus 2 omega squared. So this is the cube roots of any number you can find out, not only 8, 27 or any value. Any value can you find out, only omega square attached in second to complex numbers. Okay, so next come to the next topic. Okay, if 1 omega and omega square are cube roots of unity and small n is the positive integer, then 1 plus omega to the n plus omega to the 2n equal to 3 when n is multiple of 3 and 0 when n is not multiple of 3. So now check it. So n is multiple of 3 when n is multiple of 3. Multiple of 3. Multiple of 3 means suppose 3m. Let what? Multiple of 3, 3m. So 1 plus omega to the n plus omega to the n, 2n. Okay, so 1 plus omega to the power in place of n, what I'll write? 3m. Omega to the power 2 into n, I'll write 3m. 1 plus omega to the power 3 into m. We know that is 1. Omega to the 3 to the power 2m. We know omega cube is 1. 1 plus 1 plus 1 equal to 3. So the first case proved. When n is multiple of 3, any value multiple of 3. So we know if multiple of 3 is there, then answer will be 1. And so first case 1, second case 1, third case 1 plus 1 plus 1. That is 3. So here, if n is not multiple of 3, then what happened? If n is not multiple of 3, then what happened? Then n may be 3m plus 1 and n may be 3m plus 2. Two cases of. So one case, suppose n equal to 3m plus 1. Suppose we take n equal to 3m plus 1. So 1 plus omega to the power n plus omega to the power 2n equal to 1 plus omega to the power 3m plus 1 plus omega to the power 2 into 3m plus 1. That means 6m plus 2 equal to 1 plus omega to the power 3m. We know it is 1. Omega to the 1 plus omega to the 6m. We know it is also 1. Omega square. So 1 plus this value is 1, you know, and this is omega, and last one is omega square. So it is equal to 0. So if we take n equal to, not multiple of 3 means 3m plus 1 means we're getting remainder 1, then we're getting the value 0. The second case occurs for first case. So now take 3m plus 2. In case of 3m plus 1, if we take 3m plus 2, if we take 3m plus 2, then what happened? We'll see it. We'll check it. 3m plus 2. Okay. Now we are taking 3m plus 2. In case of n, in place of n, we are writing 3m plus 2. 3m plus 2 plus omega to the 2 into 3m plus 2 equal to 1 plus omega to the power 3m plus 2. Direct I will write omega square because I have already discussed it. So plus omega to the 2 into 3m. 2 into 3m. Okay, 6m. Plus 2 into 2, that is 4. 6m means it is multiple of 3, so I will eliminate it. So what I will write? 1 plus omega square plus omega to the power 6m plus 4. Okay. Omega to the 6m plus 4. So omega to the 6m I will not write. Direct I will write omega to the 4. But we know 1 plus omega square. What is omega to the 4? That is omega cube into omega. That is omega. So 1 plus omega square, again it is equal to 0. So now this property also completed. So now we'll come to the next property. Property number 8. So property number 8, factorization of AQ plus BQ. What is AQ plus BQ? We know in polynomial, we know the formula, algebraic formula A plus B into A square minus AB plus B square. A plus B. So A square minus AB plus B square, we are not factorizing it in algebra, but in complex number it is possible. It is A plus B omega into A plus B omega square. You can check it by multiplying these two, you'll get this value. So you have to remember AQ plus BQ. Many times it is used in every competitive exams it asks. Okay, it is asked to you. So AQ plus BQ formula, you should remember this thing. So A plus B into A plus B omega into A plus B omega square. So if you multiply these two, let me check it. A plus B omega into A plus B omega square. So A into A square, B omega into B omega square, B square into omega cube, plus A into B omega square, A B omega square, plus B omega into A B omega. So now first one A square, the last one also B square. Plus here AB you take common, so omega square plus omega square plus omega, we know minus 2. So A square plus B square minus AB. So this value A square minus AB plus B square, we can write A plus B omega and A plus B omega square. So now what is factorization of A cube minus B cube? We discussed it. A cube minus B cube. A cube minus B cube can be written as A minus B into A square plus AB plus B square. We know it, this formula. So A minus B into A minus B omega into A minus B omega square. So remember this formula is very easy. Okay. This case A plus B into A plus B omega into A plus B omega square. All are plus 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 B omega square. Remember, process very easy. And here A minus B omega and A minus B omega square. You have to remember also this. So if you multiply these two, then we definitely get this value. So A into A square. A into minus B omega square minus AB omega square. And minus B omega into A minus AB omega. Minus B omega, so multiplication is plus B square omega cube. So A square minus AB, we take common, omega square plus omega plus B square, because omega cube is 1. So omega square plus omega is minus 1. So finally this answer will be A square plus AB plus B square. So A square plus AB plus B square, after multiplying A minus B omega and A minus B omega square, it comes out. So now this topic also completed. Here you have to remember A cube plus B cube formula and A cube minus B cube formula. So now I come to next property. So guys, factorization of A cube plus B cube plus C cube minus AB. So we know A cube plus B cube plus C cube minus DABC. Its formula is A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA equal to A plus B plus C into, you can write A plus B omega plus C omega square and A plus B omega square C omega, alternatively you write, and this factorization over. If you multiply these two, you definitely get this value. Okay, so this thing also completed. So now come to next thing. What is next? So A plus B omega plus C omega square equal to 0. Suppose somewhere it is A plus B omega plus C omega equal to 0. That means definitely ABC will be same. How? Suppose A equal to B equal to C. So A plus B omega plus C omega square equal to what? A plus, in place of B, I'll write B. Sorry, A omega plus A omega square. So a common 1 plus omega square, that is a into 0 equal to what? 0. So if I'll take a equal to b equal to c, you definitely get this one. If I'll take a plus b omega plus c omega square, that means a, b, c must be contain. They must contain same values. So this property also completed. So now come to next property. If a b is a non-zero numbers means real numbers or complex numbers, so that a plus b plus c 0 and a square plus b square plus c square, then a is to b is to c 1 omega square. So value of a must be 1 and omega square, answer will be 0. Or 1 square plus omega square plus omega square, answer will be 1 plus omega square. Omega to the 4 is what? Omega. So it is also 0. So suppose you write 1x omega x omega square x. The ratio is given now. 1 is to omega square. So ABC values are, this is A value. And suppose this value is B value, this value is C value. If we add these three, x plus omega square x will take common 1 plus omega square 0. So this property also we have completed. So now come to next property. Next property, 12th number property, a complex number a plus ib, for which a is to b equal to 1 is to root 3 or root 3 is to 1 can always represent as terms of omega and omega square. This is also one property. Suppose a and b in any complex number a plus ib. Suppose in place of a, I'll write 1. Suppose in place of b, I'll write root 3. So these can be represented as omega form. How? So 1 plus I root 3. Suppose I multiply minus 1. So it will be minus 1 minus I root 3. Okay. Suppose I multiply minus 2 divided by 2. Minus 2. Okay. Suppose I'll divide minus 2 multiply and minus 2 divide. Then what happened? Minus 2 multiply. Okay, suppose I divide 2 and 2 and minus I have multiplied inside this value 1 plus I root 3. So this value must be what? Omega square. So this answer is minus 2 omega square. So here topic is this: if A and B are 1 and root 3 form, 1 plus I root 3 or root 3 plus I, then what I can do? I multiply both the side root 3 plus I and divide I also. If I multiply in the numerator, then what happened? Root 3I plus I square, that is minus 1 divided by I. So now I'll multiply 2 on numerator and denominator. 2 on numerator and denominator. Then what happened? So numerator is minus 1 plus root 3I divided by 2 into 2 by I. So in denominator I is there. Okay, so minus 1 plus root 3I by 2 is what? Omega. So 2 omega divided by I. That is no problem. So you can write it as what? Multiply I on numerator denominator. It will be 2I omega divided by minus 1. So its value is minus 2I omega. Okay. So if in place of A, I'll write 1. In place of B, I'll write root 3. So the answer can be written in omega form. If in place of A, I'll write root 3 and in place of B, I'll write 1. Also answer can be represented in omega format. So this property says this. So students, now